let's look at some binomial and radical expressions. If you have a radical in an equation, then you can use a distributive property, much like you did with any variable. So if I have a times nth root of x plus b times the nth root of x, I can factor those out, and this will be left with a plus b. And it doesn't matter whether that's a plus sign or a minus sign. The trick is these have to be the same root. So for this problem, 3 square root of 5 minus 2 square root of 5. The square root of 5x is in both, so I can factor it out. When I factor the square root of 5x out of 3 times the square root of 5x, I'm left with 3. When I factor the square root of 5x out of minus 2 square root of 5x, I'm left with minus 2. So this becomes 1, so this is just the square root of 5x. Now, for this problem, I have the square root of 7 and the square root of 5. These are different, so I can't combine these. So this is as simplified as I can get it. Now here, I have the cubed root of 7xy, and I have the fifth root of 7xy. Again, because these are not the same roots, this one is already simplified. Okay, now let's look at this one. None of these are the same, so you can't do anything, right? Not quite. Let's factor tree these out. 12 is 4 times 3, which is 2 times 2 times 3. All right, so the square root of 12 is the square root of 2 squared times 3, which is 2 times the square root of 3. Let's factor tree this 75. 75 is 5. 5 goes into 75 25 times. Now let's redo that one. I'm tired, obviously. Let's factor tree 75 out. So 75 is 25 times 3, which is 5 times 5 times 3. So the square root of 75 is the square root of 5 squared times 3, which is 5 root 3. So I can rewrite the square root of 12 plus the square root of 75 minus the square root of 3 as 2 times the square root of 3 plus 5 times the square root of 3 minus 1 times the square root of 3. Now I have the same radical in all three, so I can factor it out. 2 plus 5 minus 1. So this is what? 5, 7, 6 times the square root of 3. Now look what happens when we're multiplying. You can FOIL these out. Now for a couple of reasons I'm going to do the area model on this one. 4, 2 square root of 2. So that's the first term. And this is 5, 4 square root of 2. Again, you can FOIL this out if you prefer. I really don't care which method you use. I just want to show you something. Now, the area of this square is 4 times 5, so that's 20. The area of this square is 5 times 2 root 2, so this is 10 square root of 2. 4 times 4 square root of 2 is 16 square root of 2. And this one is 4 times 2, which is 8 times the square root of 2 squared. So this is 8 times 2, or 16. Now, your cross terms are going to add. So I'm going to have 20 plus 16 root 2 plus 10 root 2 is 26 root 2. plus 16. Collect like terms, 36 plus 26 root 2. When you multiply two of these equations together and they have the same radical, you're going to get this nice sort of answer. Now, what about when you have a negative sign? Exact same. Because I did area model on the last one, I'm going to FOIL this one. So FOIL is front, outside, inside, last. So the front, 3 times 5 is 15. Outside, this is plus 3 times the square root of x. Inside, minus 5 square root of x. Last, this is going to be minus the square root of x squared. So this is going to be 15. Collect these. Minus 2 square root of x minus x. Nice. And you're done.